Okay, so just to go over a couple of the rules that were covered in the textbook on probabilities. The rules that the textbook says is that any experimental outcome, so remember you have an experiment and it has an outcome and a sample space. A sample space is all of the possible outcomes. It's all the possible outcomes of some experiment. And then an event is something we want to know the probability for. So there's an event, and the event is a subset of the sample space. So we could say, hey, what's the probability of this event occurring? And that event that we're defining, we define that event so that we could find the probability of it. That event is a subset of the sample space, and that event could also include everything in the sample space. So we have an experiment, and then an experiment will produce outcomes, and then the sample space is all of the possible outcomes, and an event is a subset of the sample space for which we want to know the probability. So here are the two rules of probability is that any outcome, right, needs to be between 0 and 1. That's just the continuum, the scale by which probability is measured. So the probability of any event, any experimental outcome, is going to be between 0 and 1. And the sum of all probabilities for all experimental outcomes in a sample space must be equal to 1, right? So if we're tossing a coin, the probability of heads and the probability of tails, when you add those up, they have to be 1. Or if we're rolling a die, a single die, the probability of us getting 1, 2, 3, 4, 5, or 6, the probability of each of those individual sides coming up, when we add up the individual probabilities of each of those sides, then the total probability has to be 1, right? Because we're going to get one of those sides. When we roll dice, we'll get one of the 6 sides. So that's what these two rules say. The probability of any, we run an experiment, we get an outcome. The probability of any outcome or any event needs to be between 0 and 1. And when you look at the sample space, the probability of all of the different outcomes in the sample space, and this is the notation the book uses, so I keep wanting to say event when I look at that E, but all of the probability of all of the different outcomes in the sample space, when you add them up, that also has to equal 1. Cool, so that's just what's covered in the textbook. I want to make sure that you saw it. Next thing we're going to talk about is like if we were to do like multiple steps. So if we had multiple steps in for each one of the sample points in our sample space. So here we're looking at if we toss a coin twice. This is our sample space, this S. In the first toss we get heads, and then what's the second toss? It could be heads or tails. Or the first toss we get tails, and what's the second toss? It could be heads or tails. So our sample space is these 4 possible combinations. We have multiple steps. We're tossing it once, we're tossing it twice, 2 steps, right? And these are our sample points. So this is our entire sample space. And so how do we know, like if we had 3 steps, how many possible sample points are in our sample space if we had 3 steps? So multiple steps. And the rule for that is this. So it's pi, which means multiply, and we're multiplying from 1 to n ki, where k is the number of outcomes on each step. K is the number of outcomes on each step. And so for tossing a coin, there's 2 possible outcomes on the first step. For tossing a coin again, for the second time, 2 possible outcomes on this step. And when we multiply 2 by 2 here, we get 4 possible sample points in our sample space. So how many sample points would be in the sample space if we had 2 outcomes for 3 steps? If we had 2 outcomes for 3 steps. So it would be 2 times 2 times 2, and that would be 2, 4, 8. So we'd have 8 sample points in our sample space. And to see what this looks like visually, we have a thing called a tree diagram. So we start off, we toss our coin, we could get heads or tails. And then, right, that's 2 possible outcomes, right, for this first step. For the next step, whether we start from here or here, we have 2 possible outcomes. So the number of outcomes for each step, we multiply 2, that's the number of outcomes for the first step, by 2, that's the number of outcomes for the second step. And you can see that if we went here, right, we toss it, we have 1 of 2 possible outcomes. Let's say we ended up here. We toss it again. We have one of two possible outcomes. And so 2 times 2 is 4. There's 4 possible total outcomes. Well, if we ended up, let's say, here, and then we toss it again, we have 2 possible outcomes. So we would have 2 outcomes here if we ended up there, 2 possible outcomes here if we ended up there, 2 possible outcomes here if we ended up there, 2 possible outcomes here if we ended up there. And so, you know, for the third step, this is the first step, this is the second step. For the third step, again, 2 possible outcomes depending upon which one we're starting from. So to figure out how many sample points are in our sample space, we multiply, right, the number of possible outcomes on each step. So the first step has 2 possible outcomes. The next step has 2 possible outcomes. The next step has 2 possible outcomes. So 2 times 2 times 2 is 2 times 2 is 4 times 2 is 8. So we'd have 8 sample points in our sample space. And so that's how we figure out how many sample points are in our sample space when we have multiple steps. We're looking at how many possible outcomes are there on each step. How many possible outcomes are there in each step? All right, so that's the first thing that we're looking at. This falls under this category called counting rules. And this first counting rule is referred to as multiple steps in our textbook. Though sometimes in other places it can be referred to as the multiplication rule. And so again, terminology can differ depending upon the source you reference, and the multiplication rule can refer to something else also, which is why maybe our textbook just refers to this as multiple steps, not to confuse people, right? But the field of statistics in and of itself is confused because they refer to this right here as the multiplication rule, and then later we're also going to see there's another multiplication rule. And I'm being very methodical in how I talk because the terminology here requires that I move with precision to make sure that I use the right terms when talking about all this. So that's multiple steps. And in the next video, we'll take a look at like figuring out like if we have combinations and permutations, what's the difference between those two? And permutations, order matters. Combinations, it doesn't. And we'll see how do we count in those situations. So we'll see that coming up in the next video.